Ta-da! Hello, everybody. So let's see. Yeah. Whoops! I pressed the wrong button. Give me 1 second. Awkward. Professional streamer here. Don't worry. How do I get rid of it? I have no idea what I did.
Good job.
I've never clicked this button before. I thought this was the different button. I wonder what you guys can see on stream. Give me 1 second, please. Okay, there we go. I fixed it. So how do I get rid? Okay, there we go. Looks good. Hello, everybody. So yeah, this is the, I think, 7th or 8th. I don't even know. Like some number of podcasts. And I'm finally able to have my wife as a guest, which, yeah. I'm very excited about this. By the way, please let us know if the sound is not right, because I've never used this microphone in its two-way capacity until now, right? It should normally grab sound from both sides if we set it up correctly. So hopefully you can hear us fine. Yeah. Anyway, so let me try to introduce my wife. So how would I introduce you? I should have thought about this before, right?
Yeah.
Probably. Well, I mean, let me try to do some sort of introduction, right? So she has a PhD in math, right?
Yeah.
And then you're teaching various courses, but in the computer science department, right? So you kind of swayed slightly away from the mathy part and doing more computer science related research.
Well, theoretical computer science.
Yeah, sure, theoretical. I mean, since it's in a university, it's kind of, yeah, it's obviously theoretical. Okay, thanks. So sound seems to be fine. Cool. Right, and then usually most of your research is in logic.
Yep.
And like is it a specific area of logic?
Yeah, well, more non-classical logics and, more the algebraic and semantic approach. So this is what I've done so far. But
Okay.
now I'm interested in maybe exploring also syntax and implications to other areas.
Okay, cool. And we'll get into that in some more detail in that,
Okay.
but and then what else? Like professionally, I'm not sure. Professionally, you'll probably be a lot better at talking about these things than I. So we can talk about more of areas of interest for you, and then maybe some things that we are interested in that you know a lot about, but maybe don't do active research in. But
Yeah, sure.
right. But then, other than that, obviously you're my wife, right? So, and we've been married for what? 5 years? 4 years?
And now it seems like forever, but actually just 4.
Oh yeah, we are having a drink.
Yeah.
So please do not judge us. It's early.
Cheers.
It's like 4 p.m.
Come
for
on,
us.
it's lazy Sunday. It's fine.
But it's a Sunday, and we have a 1-year-old daughter. So we don't get this is maybe the second time we use these glasses
Yeah, okay.
since she was born. So please no judging.
And actually be able to spend 1 hour without
Oh yeah.
our wonderful daughter.
Did we
so
ever do that until now?
no,
No,
I don't think.
I think this is the first time we were spending a couple of hours without our wonderful daughter. So,
Yep. So
anyway, so yeah, well, obviously I gave that to her, and the mother of our daughter,
Yeah.
right? And then she's just to share it with us. Yeah, well, I mean, this is kind of fun for us, right? There's not a lot. I don't want to say that. Okay, it's we don't have any other choice to be here because we like being here. But it's not like there's a lot of things we could be doing with all the COVID madness and so on. It's hard to go outside, to go to a restaurant or something like that. So,
Yeah.
and we're both nerds. We like
Yeah.
this sort of thing. So,
I think that's the main reason.
right. So yeah, that's. I mean, I don't know what. Okay, one thing that I should mention is this is the first time she's live on Twitch or pretty much anywhere else for that matter.
Yeah.
She's done presentations at conferences, but that's kind of her she's amongst her peers, and that's not as stressful. But she was very stressed before. She was looking forward to doing this until now, but literally 2 hours ago she started freaking out. So, yeah.
But I just forgot the hour, so it was okay.
Well, anyway, cool. So let's see. Was that a reasonable introduction?
Yeah, thanks.
Okay, cool. So then I guess I usually usually the guests that I have, we kind of like know some things about them, but like I don't assume
You
that
don't know
anybody,
anything
well,
about
not
me.
me, but I assume that like the whole chat, right? So I guess we kind of glanced over it, but like how do you go from like did you want to do like math and computer science since forever, or like did you decide at some point? How did you get into like math and computer
I think
science?
it's quite funny, the story, at least for me, because during high school I discovered programming, because we do like basic programming during high school classes and so on.
Yeah, I think it's pretty much mandatory, right, for everybody, whether it's fewer or more hours. But
yeah, I had the more hours. I was in a more intense classroom, and I was super sure I wanted to become a programmer. So that was my goal. So I went to the University of Computer Science, University of Bucharest. And well, actually, I did pretty bad at the admission exam. What?
so he means like programming in the basic programming.
No. Actually, we were doing like
Yeah,
C.
I think over here it's usual to do C, but then like back in our day, like what 20 years
old.
ago,
Yeah.
it used to be either C or Pascal, but I
Yeah.
think now it's only C. I don't think they do
I think they
Pascal
do.
anymore.
Yeah. But it was actually just studying algorithm more or less. So
I mean, they call it C++, but it's not C++. It's C with the as like C in and C out.
yes, exactly with
But yeah, it's C. It's literally
just
C.
input output.
Yeah, they don't use any classes, any
Yeah.
templates, any C++ features. It's just
it's
C
just,
with C in and C out for whatever reason.
Yeah. So, and actually, as I said, I did pretty bad at the admission exam. I thought there are 3 hours of my life that I really don't remember anything. So I was on the borderline of being of entering the university.
So you barely made it.
Yeah, I barely made it.
Mm-hmm.
And at the end, I think with my parents, we choose an safe option, so to say. So they put me on paying for the tuition to attend the university, which was really not something common, because usually in Romania university is free, so you don't have to pay for it, which is wonderful thing.
Yeah, but the admission is like depending on the like the how well you do in the exam, right? The grade you get in the exam. And if you're at the border, you can maybe choose something that you assume will be less popular.
Yeah.
And then you can maybe either get in, or maybe you choose to pay. And then there's like, and again, like paying is okay. If you're from the US, it's nothing like that, right?
I mean,
it's still very little.
Still,
so
yeah.
It's something, but it's not like
So
nothing
I was
compared
happy
to,
my parents could help me with this problem, and at the end somehow I ended up in my first year just staying in this paying for the first year, and I think that got me really motivated, and so I was like, okay, what did I do there? So after the first year I passed with the highest degree or my exams, and then they said, okay, maybe we should move you from paying to not
so you
paying.
got top grades to all exams,
Yeah.
and then they moved you from paying to not paying because you were...
And during this process in which I was trying to learn a lot of things, and
so I did that with math, and in that year there was an NC. What's NC for math for the first year time ever for that university? I'm not sure what NC is, Christoph. National competition? Oh, grade gap where you get admitted or not. Oh, okay.
Okay. Mm-hmm.
Yeah.
Yeah.
I think like for this university you did like you had to do math and some programming, right? It's kind of like you had to do
like
both.
the admission.
And the admission, right?
It was just math at that time.
Just math,
now some computer science, some algorithm test is mandatory. But at that time it was just math, and I remember I had algebra and geometry or something like this. But I've told you, don't remember those 3 hours, so
They don't exist anymore.
they don't exist.
Okay.
Yeah, so as I got motivated to do better in my studying and so on, and well, I wanted to be a programmer, but then at the university in the first year, at least here, they also put a lot of more theoretical classes, and of course we also had geometry and algebra and
so like over here in Bucharest we have quite a few options for like computer science, right? We have the university where you went, and that's the more like computer science and more theoretical part. There's the Polytechnic, which goes more into physics.
Well, it is a Polytechnic,
also,
so
but also
should
like
be.
Programming, more programming than like theoretical computer science.
Yeah.
They do some,
also
of course, but
physics, and they also do the hardware part.
Hardware, electronics, and so on. And there's no electronics at all, right, at the university, computer science.
No.
And then there's like more economics, like like
there is also
computer science plus economics kind of thing. But this is the place where you also get some computer science theory. So it makes sense.
Yes, exactly. So it makes sense to study the math before. And during that year, I had a class on logic. And it was, I still remember, it was, so can you imagine, you are 18, you get at the university, you're in your first year, your first contact, and in that autumn, one of the first classes was the logic class. And the professor, wonderful person, but he looked like he was in his 60s, and he had this really friendly face, and he looked so warm and so on. And then he started to write things on the table, on the blackboard, and they were like, okay, he was using Greek numbers. For us, was like, oh. And then
wait, what was he using?
Greek numbers.
Oh, Greek letters.
Letters, sorry,
okay.
Greek letters, numbers, Greek letters. And for us, this already felt like, okay, what's going on here, and so on.
Did he just start writing proofs as well?
Well, actually, that was the tricky part, because he was writing the statement of the theorem and then proof 2 points and said, okay, this is an amusement time for you. And then next theorem, proof 2 points, trivial. Then, and for us was like, okay, he's joking. I mean, he's mocking us. What is he doing? And so we felt terrible. And I was, the first exam period was approaching, and I was terrified. Okay. Yeah, and I was like, oh, what am I going to do? Yeah, what am I?
But I think he literally said this is a moment of amusement.
Yes, amusement. He used. I mean, I think I can recover my lecture notes, and you could see, okay, amusement, and I was like just writing a sad face.
Something like, I think that a good translation would be amusement opportunity for this student, right?
Exactly.
Where you can figure it out on your own, something like that.
Yeah, and then of course. Before the exam, as a good student, I started to take the
actually try and do the proofs.
Trying to, I had, I don't know, maybe 5 days or a week to prepare for intense for the. I mean, I was going in the class and everything, but I was understanding something, but I was not getting the feeling. So I was preparing for the exam, and I went through the lecture notes one at a time, and then somehow after reading and spending some time, they started to make sense. And actually the proofs were, I mean, I know it sounds cheesy, but actually the proofs were trivial, so they were trivial.
Turns out he was right.
He was right. I mean, he was really not mocking us. And then at the end, I remember we had like 14 courses, and on the last course, he was proving a completeness theorem for propositional logic, which is one of the basic results you do in logic. And I actually got it. I understood the proof, and for me it was now it was just propositional. So what's Gödel? You mean Gödel?
Gödel, I think it probably means Gödel, but
yeah, no, it was. No, well, we can speak about this, and I will be really interested. But at that moment, he was just doing propositional,
classical
propositional logic.
You only have like and, or, not.
Yeah. I mean, the most trivial one you can do
you
with
don't have for rows, you don't have variables. It's just literally like the simple. No, that's the Gödel incompleteness is.
No, we were doing the basic step you could do in logic, like completeness theorem. But he was proving it not with truth tables and so on. He was building an algebraic proof of that theorem, and I found it it was the first time I saw. I mean, in high school when you do math, you don't see proofs, right? You receive a formula and you say apply it, and then you're like, okay, whatever. But then it was the first time I could understand a proof. I saw a proof, and it felt magic for me that it used all the other 13 courses that he did. So he built his entire course just to prove or give a beautiful proof of that theorem.
So
and
like
for me that was
like this build up where
yes,
he laid the foundation,
yes,
and in the end, okay,
and for me that was just beautiful, and I think that broke me. That was the moment in which I got broken. So.
And also hello Lexi, welcome. And
yeah, how do you do it with algebra? So it is quite nice. I mean, if you organize the all the formulas in your logic, you could organize it and put them in some special classes or boxes, or think whatever you want, and you can organize it as an algebra. So at the end, you build a Boolean algebra for propositional logic. And he was, well, I think most completeness theorem, as far as I remember or know, you prove them by counterposition. You suppose it's not true, and then you build a special model for your formula in a special Boolean algebra, and you show that it doesn't take the value you are expecting, like
the type of proof that I'd consider cheating, right?
Yes, exactly. I knew Vlad. I mean, I was playing with him because I knew he would say this, like, okay, then it's not a proof. So, but yeah, this is how he was doing.
Right, because like usually when I think of the reason I got into logic and type theory and so on was due to FP, right? And then, but you have to have like this constructive types of logic in order to be able to transition between type theory and so on.
But in math, most theorems
proofs are
by assuming it's not, and then proving.
I guess it turns out that they're a lot easier to write like that, right?
But I mean, if you want to search more about how you prove it with algebra, you have to take what is called like the Lindenbaum-Tarski algebra, in which you, as I said, you put the formulas which are equivalent in some classes, and then the ones you could prove, they are in a special class, and you want to show that your formula is in that class.
Yeah, and there's hints that even in the PureScript prelude, right, where Boolean operations form a Heyting algebra, right? And it's kind of...
Yeah, I mean, that's... behind every logic you could build a type of algebra.
Mm-hmm.
So, depending on what you can express and what you can prove in your logic, you have... oh, hi.
Hello, Yuki, welcome.
Hello.
So yeah, I mean, this is sort of like, this is interesting, right? Because like this is yet another area of math that we could probably draw parallels between, like logic, type theory, category theory, but also algebra is also very interesting.
And sometimes the results you can obtain or you can translate from algebra are quite strong, and we can discuss about this.
And also there's a certain kind of reasoning you can do with algebra that helps you a lot, and this is used a lot in libraries like QuickCheck or QuickSpec, or like, for example, Sandy's new book with like algebra-driven design.
You told me about that.
He like razor sharp focused on algebras, and you just define your program as algebras and do properties, and then I haven't gotten into reading, just I only read part of it, but it sounds very like it's an interesting.
Yeah, also to me it sounds magic, because, well, not magic, just wonderful, because magic means you don't understand it, right? Or
I'm not sure.
Yeah. But anyway, I'm really interested to look at the approach from computer science to algebra, because I'm more used to the approach from math. So,
Okay, fair enough. Okay, so then let's go back to our original story. Okay. Then we can maybe trace back to... No, don't worry. It's impossible for this not to happen. So, but I have to be the bad guy and go okay, please. Wait, I have to be the moderator for a bit. Okay, let's circle back, right? So we were saying that, okay, so you got into university, and then there was this like course, the logic course, which you kind of went into and solved all the amusement exercises.
Yes, exactly. And I realized, and I realized there is this whole new area that you could explore, which was the theoretical part of computer science. At that time, I didn't even know you could go back to computer science. I just found it fascinating. And then the professor was a really professor. And then because I remember in the second year I followed another course with him, and during a break he asked me if I would like to for him to give me some materials, and I went, and he had this big wardrobe with locker with a lot of stuff, and he just grabbed all he could find in there, like old PhD theses and master theses. And before, so nowadays when you publish a paper, you just get an electronic version, but at that time they were sending these prints of booklets, small booklets from with your paper, and he had
like a conference or like published booklet or something.
Yeah, but not the whole journal, but just your article.
Oh,
so they look just your paper.
Did you even send the whole thing?
Yes, exactly. Just your paper. So it was. They look really nice. I still have some back home, and they were like really small. And so he just basically he threw at me everything he had there. Of course, I couldn't even understand the titles. Maybe still I am not being able to digest all of them. But he just gave me all the material he could find. And I have a friend, Andrea, she remembered when I got back in the class, I was having a pile like this with all the stuff he could give. So, and I remember in the next year I went home, and every time I was just looking through them and so on. So that was an amazing exercise. I was exposed to things I barely understood, but then that was my first contact with how you could do research. So
okay, well, I guess the ones that are like thesis papers or so on probably a bit more approachable, because those usually have a good introduction and they explain things.
Exactly.
But like the actual papers were probably pretty hard to get, right? Didn't that like turn you off in a way? Like, hey, I don't get any of this. This is so foreign.
No, I was quite naive at that time. No, no, I wasn't. And then my path was just straightforward. I don't know if I was not thinking too much about it. I just went, and then I enrolled I did my PhD with him because I really just wanted to work with him. I knew he would retire soon, so I just wanted to work with my professor. So it was wonderful period. I didn't had a lot of thoughts about it, in the sense that I just did this. It felt extremely natural for me.
Oh, so, cool. Yeah. And I guess like a big pivotal moment in all of this was, I know this about it, so I'm going to mention it, right? Was when you kind of asked your parents whether they would be okay with you doing this, right? Because over here, and especially back then, which was like 15 years ago or something, maybe 10
So I finished my PhD in 2012. So I
almost,
enrolled 2008.
Almost 10 years, right? No, sorry. 10 years, right?
Yeah, 12 years.
Before you started your PhD.
Yeah, I think I started in 2010 or something.
Yeah, so like over here in Romania, the kind of salary that you can get as a professor is very, very low, especially in the beginning. Yeah. Like even now, I think in the beginning is very low. Like the entry level.
Yeah, but I was teaching some classes, but I wasn't counting on that. But I know what Vlad what he mentioned, and that was, I had the opportunity that I could do the PhD because my parents said, okay, look, we are going to support you in doing whatever you want. So that's why I maybe didn't think too much on doing this, because I never look at it, thought, okay, will I find a job after that, or how will I going to support?
And even if you do find a teaching job, right, that's like you
and then
support yourself
this,
at least the first
yes, exactly,
years,
and then this aspect that it's so thanks, mom and dad.
Yeah, cool. Okay, so then I guess what should we talk about next? Do you want to briefly mention what you did during your PhD and then after, or if you think it's relevant?
I don't know. After I finished my thesis, I somehow switched to another topic. So I liked the topic of my thesis, which was about non-classical logics with non-commutative conjunctions.
Okay.
Like you would say, I put my socks and my shoes versus I put my shoes and my socks. So that, actually So
it is the logic where just the conjunction is not commutative?
Yes, but that creates some other problems. Okay. And the main motivation for having this kind of logics, it's a AND.
It's the end.
It's at
right?
the end. So you have an end which is not commutative.
What do you have against commutativity?
Yeah, exactly. So the main argument was for this kind of logics to exist was a pure algebraic one.
Okay.
And my professor said, okay, let's look into this. And at that moment it felt up, so this is super exotic. Okay, I'm gonna do this. So didn't think too much about it. But then after finishing my thesis, I still lacked the motivation why. But I still think there is something that should be explored. But yeah,
okay.
It's still, I wasn't able to do it during my thesis, and then I just put it in the background.
Is it a subject that's still explored mostly in South America? Or is this not the
no,
same?
it's not that one. It's not that one. No.
That's a different topic. Okay, never mind.
No, it's not that one. So yeah, I don't know. I will.
Okay, cool.
I didn't give up on that, but then I also started to explore other areas.
There's so many things that there's so many areas you could explore in.
Yeah. Yeah, of course.
Like even in the small like sub areas, there's so many sub areas that you could explore.
And then after that, I went and I did a postdoc in Switzerland with George, wonderful guy, and there I explored some model logics, of course, exotic model logics like non-classical model logics, and that was fun. But I stood in my abstract world for a lot of time, and somehow now I've tried to also combine it with reality,
practical.
right?
So
some practical.
I have a fun story about that.
Yeah, because then my husband will always say, but what do you do there? So okay, you can tell this.
So there's this story. It was like kind of the beginning of our relationship, and that, by the way, that started in Bern for some reason.
The relationship.
The relationship.
But the friendship started before.
We met a couple of years before, and then we started our relationship while she was in Bern, and I flew there back and forth for like.
Vlad doesn't fly.
Oh yeah, I hate flying, but
He
that's a story for another time. Anyway, so she was kind of telling me what kind of paper she was working on, and I was like, and I don't remember anything about it, but I remember this, right? She was kind of giving me the abstract version of, okay, it does this, and this kind of like she was saying earlier, non-commutative, disjunction, whatever, conjunctions, blah. And I was like, this close of getting it, right? I'm not kidding. I was this close of understanding, like, okay, I think I get it, but can you give me an example? And I'll never forget the look she gave me. Like, I felt like a complete idiot in that moment, because like complete disgust, right? She was like, what do you mean an example? And then like, what do you mean an example? How do you think about this thing without an example? Yeah. And she was like, why do you need an example? I gave you the like abstract explanation. Why do you need an example? and to this day, we still have this problem sometimes, right? Where I'm amazed at how like she was able to train her brain into not needing examples and understanding things abstractly, and that I'm not quite there yet.
I don't know if this is the right approach or not. This is how it went for me, but I don't know if that's the approach.
I don't know, but for example, I'm always like, she doesn't really know a lot of FP, and the little bit she knows, like it's like from our conversations, she read like a couple of chapters from the Haskell book, but not too many, and she played a little bit of PureScript, but not too much, right? Just a few lines of code. But like the thing that always amazes me is that you, like, I can tell you, like, you know that joke with like, a monad is just an end of functor in the category of functor, right, or whatever, in the functor category, end of functor category. I'm like, oh, okay. I think this is like the one time ever where this explanation actually helps somebody, right?
Yeah, but sometimes I wish I would be able to give more examples or explain in.
I mean, sure, the grass is always greener on the other side, right? Because I wish I was able to read McLean and just go, oh, okay, cool, and now I know category theory. That's it, right?
Yeah.
So
But
okay, cool. So yeah, and then blah blah blah, we had a baby, right? No, I mean seriously. Like after that, we started like at some point during our like relationship/marriage, we kind of learned about. And was it you that found that talk or was it me? I don't even remember. Like the Wadler talk. I think you found it first and gave me the link to the paper, and then I found the talk and sent it to you as if it's something that I've just discovered and it's new. But you had sent me the paper a long time ago.
This is how you do in a marriage, but
anyway. But yeah, I mean it's and kind of like as we were watching / talking about that proposition as types paper, we kind of realized that there's maybe a lot more common ground than we thought there was previously. I think that's when we started talking a lot more about science between each other, right? And like starting to have some ideas. Oh, hey, Bolt, welcome.
Yeah, I think until that point, I think we were listening to each other on what we were working, but from that moment we somehow started to have also this in common, like the scientific
I think more of a common language.
Yes.
Right?
Yeah.
Because you kind of like neither of us saw the deep connections between like logics and type theory and even category theory and so on, and now we have a more common language.
Yeah. Well, and I was also I'm always fascinating about how Vlad is speaking about what he's doing, and he's always so passionate of what he's doing. So, and I was like, okay, I wanted to be able to speak with him more about this. So, okay,
cool. Okay, I think that was the. So is she familiar with the theorem provers and the Curry-Howard isomorphism?
Yeah, this is exactly what we were speaking now.
Yeah, we were talking about the Wadler's talk, and that we were referring his proposition as types, which is pretty much a talk about the Curry-Howard isomorphism.
I'm Denisa. Hi.
What does she think about using computers to prove math stuff? What do you think about that?
Well, I think it will be. I mean, it's so frustrating. I think this happened to. I cannot generalize, but I think. Okay, I will say, from my perspective and what I know from my colleagues, there is always this point that you do your research, you publish the paper, and then 1 year later, when you go back to your paper, you find so many mistakes that I mean, it's not that they break necessarily the statement of the theorem, but you do in the proof, you always end up doing small mistakes. I mean, I think it's I mean, I don't know if it is inevitable, but I think a lot of people, I would say that a lot of researchers do this. I mean, it happens. It's
usually
easy.
Minor mistakes which can
exactly. They are just minor
around.
Mistakes. Minor mistakes that they don't affect necessarily of course
results,
there are some
result.
which affect the results, but I mean, I was just referring to the ones that are not affecting the statement necessarily. But so I think it will be nice if we will all verify our theorems formally. So yeah, I think that's something nice. Of course, then I don't know, probably there will not be so many papers published, in the sense that it will take you way longer to finish a paper than happens now. But I think it will be much. It will be nice.
It might incentivize teachers to actually teach these sort of provers as part of their courses, and maybe have PhD students or master students who maybe help translating
and
the boring parts.
I would suggest to do this, maybe for computer science, if they want. Of course, it would be nice to learn about theorem proving and prove their, I don't know, compilers or things like that. But I will also teach this in math, for math students. I'm new at this, so we had a discussion. I worked a bit with Coq because I was working at a company, and somehow for them it felt natural to use Coq. So I got into using that approach, which I think it's nice. But then I also
for
know
real research, that's still a de facto standard.
Yes.
And then Lean is coming strong from behind, but
I know.
Like Idris and Agda are not even close for most parts of math.
And I don't. Yeah, exactly. I don't know for math, but I think I would suggest. I mean, I think it would be good also for math students who they don't necessarily take computer science class, to learn about how to use a theorem prover, even of course not understanding what's behind and so on, but just to learn it as a tool in their approach to math.
Yeah,
So
I think it could make like that logic course that you're talking about. I think it could be cool for more fun for a lot of more students if you'd be able to do the proofs in.
Well, I meant something different because that was a class for computer science. I mean, also just teach the math students in the last year or in the not maybe now, but before that. Just
I think there are some people doing that. But
yeah,
it's
I know
right?
from you. It's
just,
not a standard, so
yeah, for sure.
maybe more students should have access to this kind of courses. So
Okay.
for example, at the University of Bucharest, we don't have even for computer science. We don't have a special class about this, but we had some optional ones, right?
Yeah, like we had but it didn't even count as anything, right? We just did if you're interested, join our like evening seminars where we do this, and it was you and me and a few, like one other professor from the university, and then a few students who were like, a few of the top students, right, who are the people interested in doing the extra. Probably pour logic papers to a theorem. The problem with that is you need to start from like 1940s or whatever, right? Because like you usually build up, right? You build, right? You build the next paper on top of like some other theorems existing, and if you want to prove your paper now that you're publishing now, you need to spend like months and months to port, like to have the libraries and the mathematical objects ported into the language or like as libraries.
Yeah, I mean,
if they don't already exist, right? So it's a lot of work usually.
Yeah. But I think it would be nice. I mean, maybe some students could spend time in. Or, I mean, not even students. I'm not saying this, or even researchers. They could spend time implementing some part of the previous research into theorem provers.
I think
build
there
a foundation
are some universities and professors
who
do that, but not a lot. But there are some who are like building libraries for like either Calc or like Agda, and I know for sure that Lean also there's some efforts to get some like more things into Lean.
Yeah, this is something in which I'm interested in. So I don't know. Maybe I will start to formalize my non-commutative with the conjunction into a theorem prover. We will see.
Okay. Okay, cool. So then, right, and right now, after all of this, you're on a like break from university. Like
I'm a mom now.
Luckily, we're here in Romania. We get 2 years to stay at home, like paid stay at home.
I think is really important.
Yeah, and like since she works for the university, which is a like state-controlled organization.
But it's independent of your job.
Yeah, sure.
You could work anywhere and you still.
Yeah, but like if you work at some random company, the company could go bankrupt or disappear or whatever. Right? But this like you do have a like your university job on your back after 2 years, and that's a guarantee, right? There's no way that's not true. So yeah, we have, and it's still like almost 1 more year, right, of staying at home. Yeah. Okay, so so it's been like 1 year. Finally, we have a bit more time. Like the baby isn't as dependent. Kind of is, but not as much as she was.
Not as much as before. So we are starting to pick up on.
Can we get like a couple of hours?
Yeah.
Okay.
What is the best job ever?
Being a mom.
Yeah.
I guess it's very rewarding, right? It's.
Come on, being a dad is also.
Oh yeah, it's fun.
Yeah.
It's tiring sometimes, but it's fun.
Jobs are not easy, right?
Right. So I think so what's the plan for the rest of today, right? So we want to talk after I think we're going to take like a couple of minutes break, like now, but like not this second, in a few seconds, right? And after that we'll be talking about verification. I think is the plan, because you did teach a verification course at the university. It's not your main area of research in any
but as I
degree,
said, I started to flip a bit to more practical applications of research and of theoretical computer science. So that's one area that I'm.
And actually, my previous job and you also had 2 jobs at university and this other job, and it was also you're married and colleagues. At the same company. We were working for a company that does.
We really like each other, right? We spend all the time together.
So we were like working at this company which does verification, right? It's called runtime verification, and you were doing more proofs and like
as I said,
things like that. And I was working on a prover written in Haskell. So yeah, you did have some exposure to verification.
And then we will speak
even
about
practical and
And then we will speak about the Curry-Howard isomorphism
and then we have then we'll talk a bit about type theory and logic and the Curry-Howard. Well, we're not going to do it like Wadley presentation, right?
No.
We're just going to chat a bit about that sort of thing. So on that note, Yugi is going away for a few minutes. We're also going away for a few minutes, so good timing. So we will be back in a few minutes. And
then we will also announce what project we have together, right?
Yeah, and we have a cool project to announce at the end. Yeah. Okay.
That we will do.
Well, yeah, we'll see. Let's take a couple of minutes of break, right?
3 minutes.
Yeah, a few minutes.